Welcome back. This is Introduction to Probability. So, we will be talking about the basics of probability, the terminology that we use in probability. So, please make sure you have this worksheet ready with you so you can follow me along. So, let's go ahead. The terminology that you need to understand probability better is to know what an experiment is. Experiment is something that you conduct. It's an operation that you conduct under certain conditions. So trial is how many times you do the same experiment is your trial. Now the outcome is what happens after you do the experiment is your outcome. Sample space is all the possible outcomes of that particular experiment. For instance, if I am rolling a dice, that's an experiment. If I get a 2, that's an outcome. But what are my sample spaces? I can get a 1, I can get a 2, 3, 4, 5, 6. So those are all the possible. That's my sample space. Event is a subset of the sample space. Probability is how likely will that event happen? What's the percentage? What's the fraction that event will happen is called your probability. Likelihood is you are guessing how likely that event is going to happen is your likelihood. All right. So that's too much of terminology. Now let's go ahead and take a look at the problem. Three fair coins are flipped at the same time. So one, two, three. Each coin has two sides, right? Heads and tails. Now there are eight possible outcomes. You can get heads, 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 tails, tails, tails. All the possible outcomes are listed here. But what are they asking us? They're asking us, let A be the event that the second coin flipped shows a head. Now it says, identify the numbers of each of the following. First, what's my sample space? So when I say sample space, let me go ahead and show you what I mean. I can get head, 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 tail, 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 head, head, tail, head, tail, 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 head, head. So you see that? How many do I have? I have 1, 2, 3, 4, 5, 6, 7, 8. So my possible outcomes or the sample space here is 8. Now, outcome in event A. What is my event A? They wanted to have, let's say, a head on the second coin. So let me go ahead and erase this. And let's see in which case do I have head in the second coin. This one, it has a head. There you see. This one has a head in the second coin. This one has a head in the second coin. And this one has a head in the second coin. So how many do I have altogether? 1, 2, 3, 4. Right? Now, what's the probability? Now they're asking me for the probability. Remember, probability is simply the outcome of the events divided by the sample space. So here it is simply 4 divided by 8, which is 1 over 2. So your sample space always goes on the bottom, okay? So your probability of any event E is simply the sample space on the bottom by the outcome, the number of outcomes of the event. All right, now let's go ahead and do the next one. But before we move on, it's very important to know if the probability is closer to 1, it's very likely it's going to happen. Closer to 0, very unlikely it's going to happen. If it's in between closer to 0 than 1, then somewhat likely it's going to happen. If it's 50-50, it's equally likely it's going to happen. All right. A computer randomly generates numbers 1 through 100 for a lottery game. Every lottery ticket has 7 numbers on it. So the computer randomly generates numbers 1 through 100, and every lottery ticket has 7 numbers on it. Now they're asking us to identify what it is to mean an experiment, a trial, and outcome. Okay, so let's go ahead and take a look. Experiment is something that you're doing. Trial is how many times you're doing. Outcome is what you get. So in this case, the experiment is computer randomly generating a number. That is correct. Let's see, what about the next one? Experiment is computer randomly generating a number. The next one is the experiment is computed randomly generating a number less than 10. They did not specify anything for less than or greater than 10, so that cannot be my option. A trial is one number generated. That is correct. So if I generate one number, that's first trial. Generate another number, that's a second trial. So trial, so we finished with the trial. So let's see the next one. An outcome is the number 2 being generated. Remember, outcome is the result that you get. So the outcome here is, let's say the computer generates a 2 or a 3 or a 4. Outcome is what you get, the final result. So an outcome is the number 2 that's being generated by the computer. All right. Now let's go ahead and take a look at the next set of problems. All right, let's go ahead and take a look at the next problem. There are 52 cards in a standard deck of cards with 4 of each type, right? I have ace, 2, 3, 4, 5, so on and so forth. I have jack, queen, king. Now, let A be the event of choosing 7 out of a deck of cards. So I have to choose a 7 from deck of cards, right? And they're asking me identify the number of following into the probability in fraction. So if I have to choose from a deck of cards, the first thing I have to look at is what is my sample space? How many cards do I have? 52, right? So standard deck of cards, my sample size is all possible outcomes, which is 52. And from here, I am choosing 7. So let me pick a 7 here. I am choosing a card 7, right? But how many cards, how many 7s do I have? I have 7 heart, 7 diamond, 7 spade, and 7 club. So I have 4 7s. As you can see in the picture below, I have 1, 2, 3, 4 7s. Fair enough? And the probability is simply the outcome of the events divided by the sample space, which is 4 over 52. So for so good, you always have to reduce your final answer. So 4 over 52 is 2 over 26, which is 1 over 13. Fair enough? All right. If you're doing deck of cards, I highly recommend having a picture of deck of cards. That way you don't make a mistake. Now the next topic is using and or not. Okay. Simple things. And is I combine everything. Sorry. Cut. And is I find something common. Or is I combine. Negation is not. So here, the probability that we use or and not to describe the events, we can say an outcome A or B if the outcome is in A or the outcome is in B. Now, outcome A and B has to be found in both. That means it has to be common between A and B, something that's common. So the keywords I like to use or is to combine. And is finding something common, right? And not is a complement. So let's go ahead and take a look at the examples. A deck of cards contains red cards. I'm going to go ahead and write down those cards. The red cards numbered 1, 2, 3. And blue cards are numbered 1, 2, 3, 4. Let R be the event of drawing a red card, B be the event of drawing a blue card, E be the event of drawing an even number, and O be the event of drawing an odd number. So let me go ahead and highlight that. R is red cards, B is blue cards, E is even numbers, and O is odd. So drawing one red card. So that means I am taking this one red card and I am drawing it out, right? Do you see that? Now what happened? This is definitely, I'm going to use a different color. I'm going to use, let's say, green. So this is definitely a red card, right? This is an odd. This is definitely not blue, right? This is definitely not even. So let's go ahead and see which one is our options. They said drawing the red card, red 1 is an example of which of the following? Select all of them. Red card, so definitely it cannot be not red. It's a red card, that means it's not blue. Fair enough. It is red and odd. So I cannot say it's not odd. It is red or even. Yes. It is blue or odd. Yes, because it's an odd number. It can satisfy both of them. So it's blue or odd. Yes, it's an odd number. It's not blue. It's red. So everything that has those, you're going to go ahead and pick those. All right. Now let's go ahead and take a look at the next one. A restaurant is offering special chicken specials numbered 1, 2, 3, 4, 5, 6 and fish specials 1, 2, 3, 4, 5. Let C be the event of selecting a chicken special, F be the event of selecting fish special, and E be the event of selecting an even numbered special, and O be the event of selecting an odd numbered special. Now, selecting a fish special number 3. How do I do this? So I'm selecting a fish. Let me see if I can draw a fish. That's a fish. And number 3, right? So which of the following does it apply? So number 3 is definitely odd. So it's gonna definitely satisfy odd, right? And number 3 is selecting a fish. And it's 3, that means it's not even. So let me go ahead and write down. It is selecting a fish event. 3 is an odd number, selecting an odd number. If it's odd, that means it's not even. It's a fish, that means it's not chicken, right? So let's go ahead and take a look. Definitely not the first one. It is a fish special, so I cannot say not F. C or E, no, that is not an even number or not a chicken. C and O. No, it has to satisfy both. It's not chicken and odd, so not this one either. It's an odd number, so definitely not even. And let's see the next one. Fish and O. Yes, that's true. Because it's fish and it's odd. All right. So take one example at a time and see if that satisfies. All right, let's go ahead. For this one, I have to go ahead and pull up your homework problems. So let me go ahead and pull that up. All right, so this is where you have to move your dots in your Venn diagrams. So each dot outside the Venn diagram below represent a student in a particular major. The red dots represent health science majors, abbreviated as HSM, and the blue dots represent business majors. Let A represent the event students are currently enrolled in a writing course. B represents the students that are currently enrolled in a stats course. So they're asking us to arrange the dots and they have to satisfy the following conditions. Okay, so arrange the dots in the Venn diagrams and make sure the following conditions are satisfied. So both business majors are enrolled in the stats courses. So if you're a business major, both of you should be enrolled in a stats course. Both health science majors are only enrolled in a writing course. And one of the business major is enrolled in a writing course. As mentioned above, one of the business major is enrolled in both stats course and the writing course. Okay, so let's go ahead. I always like to start with the one that is enrolled in both the courses, so that makes my life much more easier. So let's go ahead and see. He says the BMI, the student BMI, named BMI, is enrolled in stats and in a writing course. Okay, so let me go ahead and take the BMI. Where is he? I'm going to take the BMI and I'm going to put him in stats and writing. You see, the intersection part is stats and writing. All right, let's take a look. And the next BM is only enrolled in a stats course. He cannot be inside the intersection because he's only in the stats course. Now the writing majors, they're only enrolled in the writing. They are not enrolled in business. So this is how you have it. Okay, so please make sure you read the conditions when you're moving the dots or the stimulations in your homework. All right, so the next one is tree diagram. It's a very important, this is the most fundamental principle of probability, which is called the fundamental counting principle. So if you have n ways of doing something, m ways of doing something, then you want to do these events in a sequence. It's simply n times m. Let's go ahead and read what it says. Suppose the first process has A possible outcomes and the second process has B possible outcomes. Let me go ahead and highlight them. Possible has A possible outcomes and the second one has B possible outcomes. Then the total number of different outcomes are simply A times B. This will make much more sense when we start doing the problems. Okay, so relative frequency, the formula is same as a regular frequency, but it's simply the total number of events in the denominator. On the numerator, you have number of times event A occurs. Okay, so let's go ahead and start with the first problem. A student is mapping out their options for their post-secondary education. They list out all the considerations. So they have two colleges to choose from. For master's degree, they have two. You see Master of Science, Master of Business Administration. For further education, they have one, two, three. Three options. All right. How many possible combination of college, master's degree, and further education are possible? So what I can do is I can go to public university, take Master of Science, and do my financial exams. Or I can go to public university, take Master of Science, and do my PhD. Or I can go to public Master of Science postgraduate. Or I can go to public Master of Science, no, public Master of Business Finance, public Master of Business PhD, public Master of Business post bachelor degree, right? So these are different combinations. So instead of writing them down, I can simply go ahead and multiply what I have. So colleges, I have two options. The degrees, I have two master's degrees, I have two options. And further education, I have two options. So 2 times 2 times 3, so I have 12 combinations. Fair enough? All right. Let's take a look at the next one. A credit card company requires that its customers choose a 3-digit numerical code. So I'm going to go ahead and write down 1, 2, 3 to access the online account. Each digit should be from 0 through 9. So let's see how many. So 0 through 9 is 10 possible. So 1, 2, 3, 4, 5, 6, 7, 7, 8, 9, 10. So I have 10 possibilities for each digit. So my digit can be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? How many different digits are there? So I'm going to go ahead and see. So the first digit has 10 options. The second digit, because they did not specify the numbers cannot repeat, I can have 111, 222, 333, 000, right? The second has 10 options. The third one also has 10 options. Using fundamental counting principle, it is 10 times 10 times 10, which is 1,000. Okay? So always keep it simple. All right, let's take a look at the next one. An all-girls secondary school has a uniform policy for its students. Students may wear the following. They can wear loafers or black sneakers. For the bottoms, they can wear black skirt, plaid skirt, black pants, khaki pants, and for the tops, they can wear black polo or red polo. These options are shown in the tree diagram below. So they did a beautiful tree diagram for you so you don't have to do all the possible options. So now, what are they asking me? What is the probability? As soon as they use the word probability, you know it has to be a fraction. That student would randomly choose a school uniform outfit with a plaid skirt and black sneakers. So first thing is, what's my sample size? My sample size is all the possible outcomes. How many do I have? You can either count all of these, or what I would like to do is I would like to simply multiply. How many options do I have in shoes? 2. How many options do I have in bottoms? 1, 2, 3, 4. Tops, I have 2. So 4 times 2 times 2. 2 times 4 times 2. That gives me 16. So my sample size here is 16. Now let's see what they're asking me. What is the probability that the student randomly chooses a school uniform with a plaid skirt and black sneakers? So let's see how many options do I have for plaid skirt and black sneakers. Where is my black sneakers? Black sneakers and plaid skirt. So going down. So this is black sneakers, plaid skirt, red polo, right? 1, 2. Do you see that? I have 2 options. So I can wear black sneakers, plaid skirt, red polo, black sneakers, plaid skirt, and black polo. Fair enough? So I have 2 options for that. So your next number of times the event occurs. So let me go ahead and write this down. Number of times the event occurs is 2. As we have seen, I have only 2 options. I can wear black sneakers, plaid skirt, and the shirts doesn't matter. So probability is simply putting that into a fraction. So number of times the event occurs is 2 over 16, which is 1 over 8, your final answer. So always start with your sample space and see how many number of times that event is occurring. Let's do one more example. I think this kind of overlapped on one another. Let's see. An airline tracks each of its airplane stops for a day. A particular airplane can travel to one of the following cities for each of its stops. New York, Boston, New York. New York, Miami, as you can see. First stop, second stop, third stop. First stop, second stop, third stop. And they're asking you, what is the probability that the airplane will not go to Charlotte? Every time they ask me that, I start with my sample space. So I'm going to go ahead and write down my sample space. Why am I starting with sample space? Because how do I spell space? S-P-A-C-E. Because they're asking me for the probability. So sample space is all possible outcomes. So here I have one option, 1, 2, 3, 4, 1, 2. So 1 times 4 times 2, which is 8. So my sample space is 8. Now the number of times that event is happening is the number of times the plane not going to Charlotte. So let's go ahead and see. New York to Boston, 1, 2, 3, 4. I can go to Charlotte, remember, so I can select this one. 5, 6. So not going to Charlotte is 6 times. So the number of times the event happening is 6. So my probability will be simply sample space in the bottom with the number of times the event at the top, which is 6 over 8, which is 3 over 4, your final answer. Fair enough? All right. And again, if you have any questions or concerns, please reach out through email or contact me through Teams. Good luck.